Welcome back to the deep dive. I have to be honest with you, and with everyone listening, I spent the last 48 hours just drowning in this stack of research we put together.
It's a lot to take in.
It is. Usually when we prep for these, I feel like I'm getting a handle on a trend. Oh, EVs are up or interest rates are down, but this feels uh, different.
It feels different because the scale has, broken the chart.
Exactly. We aren't just dipping our toes in the water today.
Yeah.
We are doing a cannonball into the deep end of what I can only describe as a total economic reset.
A reset is a good word for it.
And frankly, the stack of papers you sent over, it's heavy. It is heavy with implications, heavy with money, and heavy with some predictions that just swing wildly between utopian sci-fi and terrifying collapse.
It really is. We are looking at a convergence of ideas from some of the absolute titans of the industry.
Right.
We're synthesizing transcripts, interviews, and white papers from Dario Amodei, the CEO of Anthropic, Elon Musk, Marc Andreessen, Peter Diamandis, and Sam Harris.
A murderer's row of thinkers on this.
Absolutely. And the common thread here isn't just AI is cool or look at this new chatbot. It's that the economic physics we have lived by for the last 50 years, the rules of gravity for your portfolio, are about to be rewritten.
Rewritten is putting it mildly. To set the stage, I want to start with a phrase that Dario Amodei used. It's a phrase that it's stuck in my brain like a splinter. He talked about a country of geniuses in a data center.
It's a powerful image, isn't it?
It is.
But it's also a very specific economic claim.
Right. And I want to push on that because it sounds like marketing fluff. Oh, a country of geniuses. It sounds like something a CEO says to pump a stock.
Sure, it could.
But he's asking a very literal question. What happens to the economy? What happens to your portfolio when we take a century of technological progress, 100 years of biology, physics, coding advances, and compress it into the next 5 to 10 years?
That is the core question. We are moving from a world of linear growth, that comfortable 3 to 5% GDP growth we're used to, where the S&P 500 returns its nice historic average, into what Elon Musk calls a supersonic tsunami.
The supersonic tsunami. That doesn't sound like a gentle market correction. That sounds like something that wipes out the beachfront property.
It does, and the premise we're working with today, based on these sources, is that traditional investing rules are about to be shattered. We are looking at potentially 10 to 20% global GDP growth per year.
Hold on. Stop there.
Yeah.
20% global GDP growth. That's unheard of. That's not an industrial revolution. That's a singularity.
Exactly. And that is why this deep dive is so critical. If the world grows at 20% and your portfolio is structured for a 3% world, you aren't just missing out. You are effectively shrinking.
You're going backwards.
You're going backwards. So our mission today is to distill this massive stack of transcripts into actionable investing moves for this year. We're looking at the collision of AI scaling, energy bottlenecks, and the robotics revolution.
Right. And before we dive in, we have to do the standard housekeeping. We are analyzing trends here. We are synthesizing the viewpoints of these experts.
It's for educational purposes.
Exactly. We are not your financial advisors. If you put your life savings into a single volatile stock because of a deep dive, that's on you. Please do your own due diligence.
Please.
But okay, let's unpack this country of geniuses thesis, because this is the macro backdrop for everything else we're going to talk about.
It is, and it all starts with the marginal productivity of intelligence.
Okay, explain that. What does that mean in plain English?
Think about it this way. Right now, intelligence is scarce and expensive. If you want to solve a complex biological problem, you need a PhD researcher. That researcher needs a salary, health insurance, sleep, coffee breaks.
And maybe 20 years of education before they're even useful.
Exactly. They have to go to grad school, do a postdoc.
Yeah.
It's a long, expensive process. And even then, they can only work 40 to 60 hours a week.
If you're lucky.
If you're lucky. Amodei's prediction is that by 2026 or 2027, which, let's be honest, is practically tomorrow.
This next year.
It's right around the corner. By then, AI models will possess the capability of that PhD researcher, but not just one. Imagine a data center with 100,000 H100 GPUs.
Okay.
Now, imagine each of those GPUs is simulating a PhD-level researcher. They aren't just answering a prompt. They are reading 5,000 biology papers, formulating a hypothesis, designing a simulation to test it, running that simulation, analyzing the failure, and rewriting the hypothesis.
And they are doing this continuously, 247, no office politics, no holidays, no getting tired.
Precisely. This is what he means by a country of geniuses. He is saying we're about to have a supply shock of intelligence. When the cost of intelligence drops from $200,000 a year to pennies per hour, the output, whether that's code, drug discovery, or engineering designs, explodes.
It's like the price of oil going to zero.
It's a perfect analogy. Intelligence is the new oil, and we just found an infinite reserve.
Okay, so that's the theory. But what does that actually look like for an investor? Because explosive growth sounds great, but where does the money go? What is the up scenario here?
The up scenario is that economic growth decouples from labor. It fundamentally breaks the historical link.
The link is that.
Typically, to grow a company, you need to hire more people. You need more headcount. It's a linear relationship. More revenue requires more salespeople, more engineers, more support staff.
Right, your costs scale with your revenue.
Exactly. What Amodei and Musk are seeing is a world where output explodes while the labor input potentially shrinks or stays flat. Anthropic, for example, Amodei mentioned, they are seeing essentially 10x revenue growth per year.
10x per year. That's not a normal business metric. That's viral adoption numbers, like for a social media app, but for enterprise revenue.
It's not normal, and that's the point. We are looking at companies that can scale outputs without the friction of human scaling.
And this connects to a fascinating point Marc Andreessen made.
The demographic point.
Yeah, he argues that we are hitting this technology boom exactly when we need it most.
Because of the population collapse.
Right. I've seen the charts. Birth rates are down everywhere. Japan, Europe, the U.S.
Exactly. We're facing a demographic collapse in the developed world. The workforce is shrinking. In a normal timeline, that leads to economic stagnation. It's a disaster.
Japan has been fighting this for decades.
And losing, for the most part. But Andreessen argues this AI boom is a miraculous timing. Just as we run out of human workers, we invent the infinite digital worker. AI prevents that economic shrinkage. It plugs the hole.
So it's not just that AI makes things cheaper. It literally saves us from a slow, grinding decline. It plugs the hole in the sinking ship of demographics.
That's the argument.
But you mentioned the up scenario. I have to play the skeptic here. If robots and AI are doing everything, surely prices crash.
Yeah.
If I can generate a legal contract for free, why would I pay a law firm thousands of dollars?
That is the other side of the coin, and it's something Andreessen is very, very vocal about. Deflation. If productivity explodes, if you have a country of geniuses solving problems at light speed, output increases massively. And basic economics tells you when supply goes to infinity, prices tend to collapse towards zero.
Which sounds great if I'm buying a TV or legal services, but maybe not so great if I'm a company selling those things. My margins get crushed.
Precisely. Andreessen's view is that this is amazing for consumers. It's a massive increase in real wealth because everything gets cheaper. Your dollar buys more.
But for an investor?
For an investor, it wreaks havoc on companies that are banking on scarcity. If your business model depends on charging high fees for inefficiency like billable hours in law or slow artisanal coding, you are in the blast radius.
So the down scenario is for businesses that sell time or friction.
Yes. If you sell time, you are in trouble. If you sell outcomes, you might be okay. But the margin on process is going to zero?
Okay, so that's the macro thesis. Violent upward growth in output, potential deflation in services price. Let's get specific. Let's talk about the short list. Who is really in trouble? Because the narrative for a long time was blue-collar jobs go first, white-collar jobs are safe.
Right, the robots are coming for the factory workers?
Exactly. But the sources we've looked at are flipping that on its head.
They really are, and this is where it gets really interesting for anyone holding stock in large B2B service firms. Marc Andreessen describes this tension in the tech world right now as a Mexican standoff.
I loved that analogy. But let's break that down for the listener who hasn't been in a tech C-suite recently. Who is pointing the gun at whom?
So imagine a typical product development meeting. You have three people, a product manager or PM, a designer, and a coder.
The Holy Trinity.
The holy trinity of Silicon Valley. Historically, you needed all three.
Yeah.
They rely on each other. The PM holds the roadmap. The designer makes it usable. The engineer makes it work.
And usually, they hate each other, or at least there's friction. The design is too hard to code, or the code doesn't look like the design.
Exactly, that creative tension. But Andreessen observes that right now, each of those roles thinks they can replace the other two using AI.
Okay, walk me through that. Let's start with the coder.
Okay, the coder looks at the designer and says, with Midjourney V6 and a decent UI library, I can generate good enough interfaces. I don't need to wait 3 weeks for your Figma files. I can just build it.
And the coder looks at the PM and says, I don't need you to organize my backlog or write user stories. The AI can do that. I can talk to the customer myself.
Right. But flip it. The designer is looking at tools like Cursor or V0 from Vercel or Replit and thinking, I can just pop the code. I can describe the app I want and it gets built. I don't need to beg you to fix a div alignment. I can build the app myself.
And the PM thinks, I can just write a really good spec and have an AI agent team build the whole thing.
Exactly. Everyone is holding a gun that says, I can do your job. The result isn't necessarily that they all shoot each other. It's the emergence of the superpowered individual. One person doing the work of what used to be a 10-person team.
So if I'm investing, I should be wary of those bloated organizations that sell headcount.
Yes, that's the key takeaway. The value shifts away from large, slow organizations to lean one-person unicorns or very small teams. If you are investing in a large consultancy, let's say an Accenture or an Infosys, or even a massive ad agency like WPP, where the revenue model is we have 50,000 people billing by the hour, that model is under severe threat.
Why?
Because your client is going to realize they can hire one superpowered individual with an AI toolkit and get a better result faster for a tenth of the price. The leverage is moving to the individual who can orchestrate these AI agents.
This reminds me of what Peter Diamandis was saying about task loss versus job loss. It's a nuance, but it feels really important.
It is critical. Diamandis and his co-author Alex put out this paper called Solve Everything. Their argument is that it's not a recession we're heading into, it's that tasks are being evaporated.
What's the difference?
The job of lawyer might persist for a while, but the underlying tasks, writing the first draft of a memo, reviewing a contract for standard clauses, doing discovery, those tasks are disappearing into the software. The job becomes about editing and managing the AI's output.
And Sam Harris had that clip from Mustafa Suleyman that was pretty stark. He said, the latter is evaporating.
That's the scary part for the white-collar career path. Suleiman's point, and he co-founded DeepMind, so he knows a thing or two, is that white-collar jobs, lawyers, coders, junior analysts are going before the blue-collar jobs like plumbers and nurses.
Right. It's harder to build a robot hand that can fix a leak under a sink, which requires, proprioception, flexibility, and problem solving in a chaotic environment.
A messy, wet, unpredictable environment.
And it is to build an AI that can write a legal brief based on 1,000 precedents.
Exactly. And this has a specific investment implication. The bear case is for entry-level white-collar roles. If you are investing in companies that rely heavily on armies of junior analysts or paralegals to do grunt work, be careful. Those rungs of the ladder are disappearing. The business model that depends on training cheap young labor is broken.
But there's a flip side, right? There has to be a bull case.
There is. The bull case is for the centaur.
The centaur, like the mythical creature.
Exactly. In chess, this was the term for a human playing with a computer. And for a long time, a human plus a computer could beat a computer alone. The human provided strategy and intuition. The computer provided brute force calculation.
So that's the model for the future of work.
That's the model Andreessen and Amodei both hint at. The 10x engineer isn't just 10x anymore. They become the 1000x engineer. They orchestrate a team of AI agents.
So from an actionable investing standpoint, you want to find the companies that are tools for these super users. You want to own the saddle, not the horse.
That's a great way to put it. Or you want to own the companies that are aggressive about cutting bloat and empowering their best people. If a company announces they're laying off 20% of middle management to replace them with AI workflows, the market might panic for a day.
That's the smart move.
But in this country of geniuses thesis, that company just became significantly more profitable and agile.
Brutal, but that's the logic. Okay, so we've got the white-collar disruption. That's the soft side of the economy, the world of bits. Now, I want to pivot to the hard stuff, the world of atoms. Because for all this talk about software, Elon Musk is screaming from the rooftops about physical constraints.
This is where the rubber meets the road, or rather, where the electron meets the chip. We call this segment the tracks, not the trains, meaning that the AI models themselves, the trains like Claude or GQC4, might become commodities. Andreessen and others hint that open source is catching up fast.
So the intelligence gets cheap.
It gets cheap, but the tracks, the physical infrastructure required to run them, that is where the sure value lies. And according to Elon Musk, we are hitting a massive wall.
The energy bottleneck.
Electricity, plain and simple. Musk's warning is stark. He says chip production is growing exponentially. NVIDIA is shipping silicon as fast as they can. But electricity output, specifically in the US and Europe, is basically flat.
Flat, with all this demand.
Flat. We are not building new power plants fast enough. Permitting takes years. Construction takes years. He predicts we will run out of power to turn the chips on by the end of this year.
Wait, literally this year, as in a few months from now. We're going to have data centers full of H100s sitting dark because there's no plug.
That is exactly what he is predicting. He says the chip shortage of 2021 and 2022 is ending, and the voltage transformer shortage is beginning right now. It's the next great bottleneck.
Okay, that's a huge claim. So that gives us a very specific, actionable sector list. It's not just buy utility stocks.
No, it's deeper. It's much deeper in the supply chain. You need to get specific here. When Musk says we run out of electricity, he doesn't just mean we don't have enough coal or natural gas. He means the grid physically cannot transmit the electrons to the data centers. The choke point is the transformer.
The transformer. Not the toy, not the movie.
No. The physical voltage step-up, step-down boxes that sit at substations. These are massive, house-sized pieces of equipment. They take 300,000 volts from a long-distance transmission line and step it down to the 480 volts your data center actually needs to run.
Okay, so why can't we just build more? Is it hard?
It is incredibly hard. The lead time on these used to be 12 months. Now it's 3 to 4 years. It involves winding massive amounts of copper and high-grade electrical steel with extreme precision. It's a bespoke, heavy industrial process. You can't just 3D print one.
So companies that make these, they have pricing power for the next few years.
They have immense pricing power. And there was another specific bottleneck Musk mentioned that I had never even heard of. Veins and blades.
Veins and blades. This sounds like a Dungeons & Dragons expansion pack.
It does, but it's critical. These are the internal components of natural gas turbines, the ones that generate the power in the first place. To generate power efficiently, these blades have to spin at thousands of RPMs in temperatures hotter than the melting point of the metal they are made of.
Wait, how does it not melt? That sounds impossible.
It's material science magic. It's called single crystal casting, and they have these intricate internal cooling channels. It is incredibly difficult to manufacture. There are only a few companies in the world, like GE, Siemens, Mitsubishi, that can cast these things with the precision needed.
And what's the lead time on those?
Musk says they are sold out through 2030.
Sold out through 2030.
So if you are Google or Microsoft and you say, we need to build a new data center, we need a gigawatt of power, you can't just buy a turbine. The line for the blades inside the turbine is 5 to 6 years long.
This is the alpha right here. This is the actionable insight. If you are looking for an investment thesis, look at the companies that manufacture grid components, heavy electrical equipment, and sustainable power generation hardware.
Look at the supply chain for single crystal casting. Look at the copper miners, because you can't build transformers without copper.
It's the shovel selling strategy for the AI gold rush, but instead of shovels, it's high-voltage transformers and turbine blades.
That's it, exactly. And Musk also mentions solar and batteries. He says Tesla and SpaceX have a mandate to reach 100 gigawatts a year of solar production.
Why solar specifically?
Because if you can't get power from the grid, you have to generate it on-site. Speed is the currency. If the utility company tells you it'll take 5 years to connect your new data center, the AI companies will just go off-grid. They will build massive solar farms with massive battery backups just to bypass the bureaucracy.
So decentralization of power is a play here too. The companies building those utility-scale batteries and solar farms.
Yeah.
Okay, speaking of off-grid, let's talk about the ultimate off-grid play. Because Musk dropped a prediction about space that I honestly thought was a joke at first. But the more I read, the more it made a terrifying amount of sense.
The orbital data center.
Yeah. He said in 30 to 36 months, so 2.5 to 3 years, space will be the most economically compelling place for compute. Why? I mean, launching stuff is still really expensive.
In the past, you were right. When launch costs were $10,000 a kilogram with the space shuttle, the math never ever worked. But Musk's whole thesis rests on Starship. If Starship hits its targets, we are talking about dropping launch costs to $50 or $100 a kilogram.
It's 2 orders of magnitude cheaper. It's a game changer.
It changes everything. At that price point, the economics completely flip, because in space, you have 2 things that on Earth are very expensive, but in orbit are infinite and free: solar energy and cooling.
Okay, solar I get. It's always sunny in orbit, no clouds, no night. But cooling. Space is a vacuum. My thermos is a vacuum. A vacuum is an insulator. It keeps things hot. How do you cool a supercomputer in a thermos?
It is a challenge, but it's solvable through radiation. You use massive radiators, basically big fins, to emit infrared radiation heat into the deep cold of space.
So you just radiate the heat away.
You just radiate away. On Earth, cooling is a massive energy cost for a data center. You're pumping water, running giant compressors, evaporating millions of gallons of water. In space, once you build the radiator, the physics does the work for free. You just face the radiator away from the sun.
So the thesis is, the capital expenditure of launching the satellite is high, though getting lower. But the operating expenditure, the monthly energy bill, is effectively zero.
And for AI training runs that take 6 months and burn literally billions of dollars in electricity, zero energy costs is the ultimate competitive advantage. Plus, there's no NIMBYism in space. No one complains about the noise of the data center or the water usage.
That completely reframes the aerospace sector. I think a lot of investors look at space stocks and think tourism or communication satellites. You're saying we should look at them as the back-end infrastructure for the AI economy.
100%. If Musk is right, and compute is the new oil, then space is the new offshore drilling platform. You need to look at the entire aerospace supply chain, the launch providers, and the satellite bus manufacturers. This turns space from a speculative maybe into a core pillar of the AI ecosystem.
Wow. Okay. Moving from the stars back down to the factory floor. We talked about the AI brain, the country of geniuses. Now we need to talk about the AI body, the robotics supercycle.
This is Musk's supernova formula. He loves these formulas.
He does.
He says the value is exponential digital intelligence multiplied by exponential chip capability multiplied by exponential electromechanical dexterity.
Electromechanical dexterity. That's the fancy way of saying better hands.
It is. Musk calls it the hand problem. We have robots that can walk. Boston Dynamics solved that years ago. We have robots that can see. Computer vision is incredible. But a robot that can thread a needle or pick up an egg without crushing it or assemble a delicate circuit board, that is the limiting factor. That's the final frontier for robotics.
And Tesla with Optimus and companies like Figure are racing to solve this.
Yes. Musk calls them Optimus, the plural of Optimus. He envisions millions of them. The goal, he says, is robots making robots. Once you close that loop, once the robot can manufacture itself, the cost of labor effectively goes to the cost of raw materials and energy.
Which brings us back to the energy problem.
It all connects. But there's a geopolitical angle here that we cannot ignore. And this is where the investment thesis gets really tricky. Musk was very open about the China stats, and they are startling.
They are. I had to read them twice. He pointed out that China currently produces 3 times the electricity of the United States.
3 times.
3 times. And even more critically, China does 2 times the refining of the rest of the world combined.
Wow. 2 times the refining of the rest of the world combined. So all the key ingredients.
Down.
All the ingredients. Think about what a robot is made of. It's motors, magnets, batteries, and a frame. That means you need lithium, cobalt, neodymium for the powerful magnets in the motors, gallium for the chips, and high-grade steel. Right now, the supply chain for the body of the robot goes straight through China.
So what's the play? Do we invest in Chinese manufacturing, or is there a reshoring play for the West?
The up scenario for Western investors is the reindustrialization play, the reshoring trade.
Yeah.
Governments are finally waking up to this strategic vulnerability. You're going to see massive incentives, hundreds of billions of dollars, for domestic refining of lithium and rare earths.
So look for Western mining companies, refining companies, and material science companies that are building out this capability in North America or Europe. Because if we're going to build millions of Optimize here, we can't be shipping the ore to China and then shipping the finished magnets back.
Exactly. We need to own the dirt and the processing. And the down scenario, this is the scary one, is for Western manufacturing firms that don't automate.
What happens to them?
If China deploys humanoid robots at scale first and their cost of labor drops to pennies per hour equivalent, any Western factory still using human labor is obsolete overnight. It's invest in automation or die. There is no middle ground.
That's a sobering thought.
Yeah.
Okay, let's talk about moats. Because investing, we always look for the moat, the defensible advantage. Marc Andreessen had a very interesting take on where the value sits in AI. He compared the model to the app.
This is a debate that is raging in venture capital right now. It's the central question. Andreessen's view is that it is, at best, ambiguous whether AI models themselves have moats.
Because of open source.
Yes.
Yeah.
The bear case for the big model companies like OpenAI or Anthropic is that open source competitors like Llama from Meta or DeepSeek out of China catch up instantly.
Wow.
Andreessen mentioned that there are no secrets in the big labs. The researchers all know each other, they move between companies, the papers get published. If you spend $1 billion training a model and 6 months later someone releases a free version that is 95% as good, where is your profit margin?
It's a race to the bottom on price. Intelligence becomes a utility, like electricity. You don't pay a premium for premium electricity, it's just electricity.
Exactly. So Andreessen leans towards the bull case for apps. The moat isn't the raw intelligence, it's the workflow. It's the application that's built on top of the intelligence.
Can you give an example? What's the difference?
Sure. Take biology or pharma. Amodei talked about this too. The value isn't just asking a chatbot to cure cancer. That's not a moat. The moat is integrating that AI into a physical wet lab, automating the experiments with liquid-handling robots, handling the terabytes of regulatory data, and navigating the FDA approval process. That creates a sticky ecosystem.
So don't just bet on the company that has the smartest chatbot. Bet on the company that uses that chatbot to revolutionize a specific vertical, like law or biology or engineering.
Correct. The superpowered applications. Andreessen calls it the superpowered individual, but it applies to companies too. The company that uses AI to do biology end-to-end has a moat because of the proprietary biological data they generate and the physical lab integration, not just because they have access to the latest neural net weights.
Which transitions us perfectly to the wild cards, because Dario Amodei isn't just a tech CEO, he's a biologist by training, and his vision for what AI does to healthcare is, well, it's utopian.
It really is. He talks about AI doing biology end-to-end, not just analyzing data, but proposing experiments, running the robotic lab, analyzing the result, and iterating thousands of times a day. He predicts we could cure cancer, eradicate infectious diseases, and significantly extend longevity.
That's the solve everything thesis from Diamandis, but applied to our own bodies.
Yes, and for an investor, this means looking at biotech firms that are AI native.
What does that mean, AI native?
It means not traditional pharma companies that sprinkle a little AI on top of their old processes. It means companies built from the ground up to use AI for discovery from day one. Look for companies like Isomorphic Labs, which is a Google DeepMind spinout, or others that are essentially software companies that happen to be doing biology.
But then there's the dark side, the defense play. Amodei and Musk both warned about the offense-dominant world.
This is a chilling concept. It really is. In the past, defense was generally easier and cheaper than offense. Walls work, forts work, it's hard to attack. But with AI, the offense gets a massive, massive advantage.
How so?
Amodei warns about super-empowered bad actors using AI to design novel bioweapons or launch devastating cyber attacks that can take down a power grid. One person with a laptop could have the power of a nation-state.
And Musk talked about drone swarms.
Right. This is the new face of warfare. If you can manufacture 1 million cheap drones for $500 each and have them coordinated by a single AI, that is a force that traditional militaries struggle to stop. 1 million cheap drones can overwhelm a billion-dollar aircraft carrier.
So where does the money go? What's the investment play in an offense-dominant world?
It goes to governance and verification tech and kinetic interceptors. Meaning cybersecurity, obviously, that's table stakes, but also physical defense systems like drone interceptors, lasers, high-powered microwaves, other drones designed to hunt swarms. The Star Trek vision of liberty needs a shield.
So you're saying investing in defense tech isn't just about missiles and tanks anymore?
No, it's about AI countermeasures. It's about companies like Neural or Palantir that are building the software layer of war and the autonomous systems to defend against these new threats.
So we've covered the macro, the white-collar disruption, the energy bottleneck, space, robotics, moats, and biology and defense. It is a lot.
It is a lot, but a pattern emerges, doesn't it?
What's the pattern you see?
The bifurcation. The great divide. The investing landscape is splitting in two. On one side, you have the machine. This is AI, robotics, energy, space. These are the inputs and the engines of the new economy.
The things that build the future.
Exactly. And on the other side?
What's on the other side?
The muddle, the bureaucracy, the legacy services, the companies banking on human inefficiency, the unadapted.
So the final question for the listener is, are you investing in the inputs, the energy, the chips, the raw materials, or the outputs, which are the solved problems? Because investing in the middleman seems like a very dangerous place to be.
That's the danger zone. The middle is evaporating. If you aren't providing the power, the compute, or the final solution, you are just friction. And AI is a friction deletion machine.
I want to leave everyone with a thought from Elon Musk. that was in the source material. It's a bit provocative, maybe a bit philosophical for an investing show, but it really struck me.
I know the one you're talking about.
He suggests that in a future of superintelligence, we humans are not in control. But, and this is the key part, if we are interesting, the AI will keep us around.
It's the irony shield, or the entertainment value theory of human survival. Be more interesting than a rock.
Exactly. So, is your portfolio interesting enough for the singularity? Are you betting on the companies that are building the future, the ones creating the machine, or are you stuck with the ones just trying to survive in the muddle?
That is the question. And frankly, after this research, I'm looking at my own portfolio and thinking I need to buy more copper or maybe some space stocks.
And I'm going to go learn how to operate a high-voltage transformer, just in case.
See
We'll leave it there. Thanks for diving deep with us. We'll catch you on the next wave.
you next time.